every machine has gremlins. That's what I call them. Every machine has them.
All right, welcome everybody to the second episode of the Chips and Chat podcast, being filmed here at Hill Industrial Tools in Plymouth, Minnesota. I'm here with my guest, Matt Evans, today. Matt is a quality manager at Unimatic Precision Machining, as well as the president of Measuring Microns. So thanks for joining us, Matt. And Matt, could you just share a bit about your journey into the world of precision machining, kind of what led you to establish Measuring Microns?
Yes, thank you. I started my journey at the lowly position of deburring. I don't think it's so lowly now because I depend on the people in deburring quite a bit. But I started, they were bone screws and they had a secondary thread, and I just, and I did that all day, every day for a long time. Felt like a long time at least. Moved into quality, doing some calibration, some things like that, and then quickly made a couple of other changes and eventually wound up measuring some parts here and there and kind of ran with it. Learned CMM programming, best practices, things like that from a couple of different manufacturers, and then really took off with CMM programming. It satisfies a certain piece of my brain. I have control. Pc-Dmis specifically is a software where you have to have high control. It doesn't really do anything for you. It depends completely on you doing it or telling it what to do, more or less. So that's kind of the way that I ended up in manufacturing there. On the other side, with Measuring Microns, I noticed that there is a lack of higher level programmers that are, most people are looking for them in the very least. I know of a handful of manufacturers right now that would love to have a high level programmer. And so I saw a need, and I figured, you know what? I've got a large family at home, and I would like to be able to be home more. So if I can program a CMM from home, remotely, send the program over, we can have a good day.
Awesome, awesome. So you mentioned that you started out in deburring.
Yep.
And deburring bone screws, and you did that for a while. So how long were you doing that for?
Deburring bone screws specifically, I think that was the only thing I did for about 4 months.
Oh, wow.
So I did 4 months, and it's all under the microscope work.
That's a long time to be spending.
I think it was about 4. Yep. The really cool thing, though, about that manufacturer is after we got through the bone screw portion of because they had a huge backlog. It was actually a little debilitating sometimes because you'd come in and they had all of them stacked up, just waiting to be deburred. They eventually got it down to where it was deburred out of the machine. That's where they eventually ended up. But after we got done with that project, I got put on radial or radius plates. Mm-hmm. So it's a little plate that goes right here in your wrist. And we had huge amounts of cycle time. We had huge amounts of deburring time. I think when we first started that project, it was like, I think the machine was producing about 10 parts a day. They had 2 machines running it continually. So we had 20 parts off the machine daily. And we could finish about 10 of them in deburring in a day. So we were really falling behind continually with that project. And so I worked with the engineer, worked with the machinist. They did huge improvements off of the machine. They really spent a lot of time to where they were getting, by the end of the project, I think they were getting 35 or 40 parts off of the machine a day. And then they still had the 2 machines, so that's, 70-ish parts every day coming into deburring. And we were working on the different processes for trying to get all of the burrs off. And we got it down to, I'd have all 80 of them deburred in 3 hours.
Oh, wow.
So through process improvements and trying, trial error, like just figuring it all out, we really nailed that process down for that manufacturer. So
that's awesome. That's awesome. So moving on to metrology and metrology services, what really inspired you to focus on metrology in particular? I know you said that, you kind of got guided that way yourself, and that's kind of the way that you got led. But what really led you to focus and really make that your forte and stick in that area?
Opportunity.
Opportunity. That's a great answer.
It feels a little silly to say it, but for me, I like work. I like going, like not necessarily going to work, but doing work. I've held 1 to 3 jobs since I was 17, depending on basically other than a couple of months, it's been two to 3 jobs since I was about 17. So work has never really fazed me. And so I saw an opportunity within metrology, inspection, quality, and so where there was opportunity, I said, let's grow. I've really tried to bring a growth mindset, and basically, typically, if I'm looking at switching a job or something like that, that means that I've kind of capped out on my growth. That tends to be kind of where I hit my ceiling. It's like, okay, well, I need to grow more because I don't really stop. But which is one nice thing about Pc-Dmis is that there's almost always a next level. There's always more that you can learn. Or as we'll discuss in a little bit, it'll be the adding other softwares. It's going to be looking at other softwares, and then, you might understand CMM metrology, but now you have to learn it through another lens. And they all kind of do the same thing. All of the softwares are, they're able to do, for the most part, the same thing. There's obviously some things that not all of them can do the same, but at the end of the day, they all measure parts. And so you have to learn and have the base of metrology, understanding surface plate measurement, understanding all of the things that go into how to inspect a part, and then you can bring that into CMM programming specifically, or any other piece of inspection equipment, whether it's a optical comparator even, all the way to like an automated system like the Keyence or an OGP or the O-scope or whatever the piece of equipment might be. But I did kind of just fall into metrology. I saw opportunity and growth, and so I took it.
That's awesome. So that really is awesome. So Measuring Microns offers on-site inspection, training, and offline programming as well. So can you delve into these services and how these services are supporting the local manufacturing teams that you're working with?
Yeah. So I actually want to read a hair just because I wrote it well. I like real life examples. So last year here in the Twin Cities, we had there was a company, and they had a metrologist. He ran their CMMs. He kind of ran the entire show. He ended up getting into a really terrible car accident. And so the business went from, hey, we've got a guy, he does a great job, we love having him here, to everything's on fire, because that's manufacturing, right? Everything's always on fire if there's any lag. So they were like, we got to have some help. And so I was able to come in kind of at the end of a work day and work that later portion of the afternoon, because I still work a full-time job. And then also there was another company that I was able to take the morning portion, morning and early afternoon. So I kind of worked tandem with another consulting company for helping and supporting that manufacturer through, I can't remember exactly how long it was. It was quite a while, actually. I don't remember how long exactly I was there, but I was there multiple times a week until the person was able to heal well enough to be able to come back to work. Thankfully, as far as I know, they've made a complete recovery and everything's great there. One of the current companies that I've done some training with, so that would be kind of the on-site support side. There's a company that has been looking for a higher level programmer for probably about 6 months now, 6-7 months. I haven't really found the right person to come knocking at their door, and so they said, you know what, I think we can fill this internally. So they had somebody who had interest, and they were like, Matt, we want you to come on site. The advantages that I bring there are going to be, I'm not going to use the demo block that Hexagon gives you. We'll use it right at the beginning so you can understand a couple of the basic pieces, but I try to move on very quickly from the block that always runs perfectly onto a part that never runs perfectly. So that's one of the advantages. And the other side of that would be the being able to kind of customize to the people, right? The person that I was training, they had been through the 101 course already. I didn't need to show them every single step, but what I needed to do is backfill some of the information that they'd forgotten. I needed to hone some of the other pieces. And then, so I was able to say, yep, I'm going to give you 5 days worth of training. We're going to go as far as we can. I'm not built into, here is your 5-day training. This is all I'm going to show you. And at the end of, 40 hours, it's going to be, you're going to get me for 40 hours and everything that I can get you through. And typically, at least for most people, once you get to the end of the eight hours of me talking at you, you get the eyes glazed over and we're ready to call it a day and recoup on the night.
So
Yeah.
you mentioned a passion for teaching, and you mentioned an example of teaching right there. Can you tell me how do you approach training to help the quality departments perform more effectively? You mentioned not just the always gonna pass, but the tackling the example of the never gonna pass part,
Right.
and doing that part. So can you touch a little bit more on that, and your generalized approach to training to teach different people, especially with everybody's different learning styles?
Yeah. So one of the things I did at a former employer was I did do some training. So I've done like coursework. So I've had 3, 5, 10 students at one time. But through Measuring Microns, it's typically only going to be 1 or 2 people.
Okay.
So I'm very much able to spend a lot of time figuring out where their pitfalls are going to be in their learning process and just tailoring it to what they need. So some of the things that I do is I spend a lot of extra time typically on the degrees of freedom. So in a 3-dimensional world, you have to lock things down because otherwise they can spin and move, and that's not really a good thing. So you move your trihedron to where you need it to be, and you lock that part in with your alignments. And I spend, some might even argue, too long on alignments or the degrees of freedom, those types of things. Because the problem is that most of the time when you encounter problems on a CMM, there's typically 3 issues. 1, the part moved or the fixture moved, or the fixture is not quite right. So that's typically the first thing I look at. The next thing is going to be your alignment. So if your alignment is not set up correctly, at least for sure in Pc-Dmis, I'm sure that Calypso, CMM Manager, and all these other softwares are going to be similar. It's actually going to affect the direction or the vector of your hit potentially if your primary datum is not set correctly. So as I tell everybody that I train, a CMM is a random number generator. That it is the best random number generator that you can find, unless you can make it mean something. And you have to make it mean something through your alignments, through your fixturing, and that's how you get meaningful data to come off of the CMM. So I spend a lot of extra time teaching alignments, degrees of freedom. I actually have a test that I give people so that I make sure that they are grasping and understanding it, because otherwise I'm not moving on.
Mm-hmm.
I have to have the person at least understand those pieces before we can really keep moving, because otherwise, I mean, I can show you how to do anything you want in the software, but if you can't align the part correctly, it doesn't mean anything. So I also try to build in some kind of like a third to a half a day of discussion about GD&T, which is a whole nother fun topic, but how does the software handle it? How do you need to think about it? Because one thing that Hexagon did was in 2020 revision 2, said that incorrectly, they redid their entire GD&T library in Pc-Dmis. And so they made it more accurate to the standard. And since then, they've made significant improvements to that even. But at the same time, it limits you. Pc-Dmis says, hey, that's not a legal call out. You can't do that in this software. Well, it doesn't stop people from putting it on the print. It doesn't stop people from wanting that piece of information. It does. So if you've got it on the print, it's now, okay, it's on the print. I need to put something down on my piece of paper to say, yep, that was checked and it was good or it was bad. So how do I now go about that inside of the software? So you have to understand what it's asking for, and then you might have to move into legacy versus the geometric tolerance, or you have to report it out potentially a little bit differently, which isn't, perfectly to the feature control frame, but it's as close as you can get. Mm-hmm. So I spend a lot of time talking about those types of subjects.
Okay, got it. And now I noticed on your website you said that you've got some upcoming offerings like CMM manager training, on-site support. So what can clients expect from these new services? What can be expected when Matt shows up at your door?
So when I show up at this point, I've got Keyence, the IM series specifically. That's pretty well locked down, especially if you've got a rotary. I've got some really cool tips for that. Pc-Dmis, we can go and have a ton of fun with that software. In all honesty, I wanted to be further in the CMM manager world. I have not made it very far. Some of the different things that have happened at my full-time job, and also some of the offline programming has really kicked up recently. I've got a new client, cutting edge technology out of Tulsa, Oklahoma. Phenomenal company. But they've been sending me quite a bit of work lately. So I've been pretty much steady there. I've been working and very slowly accumulating all of the pieces in order to get an online training course put together for Pc-Dmis. It takes a lot of time, as you know, editing the videos for the podcast.
Yeah.
I'm going to be editing all of the videos so that everything works seamlessly online for somebody to go from maybe I don't know what a CMM is to I can program Pc-Dmis, or I have all of these grand ideas about having a small platform that's going to have different modules that somebody could buy. Like, hey, I really want to learn about some of the logic and flow programming that we can do with if-then statements and things like that. So maybe that'll be a small module that you could just, hey, I just need that. I've got everything else, I just want that. So I've got lots of ideas coming for that, but that one's going to be a while.
So we've got lots of offerings right now in the micro, in the here and now.
Yep.
And in the macro, you just have this whole vector of metrology training that you're working on slowly and building those blocks up. So we can look forward to not only what you've got to offer right now, but make sure that we're staying in tune to what you're doing, so that way we can follow with, as the trends are changing and stuff, you're changing with them too, and you're providing that latest training and technology as much as you can and as currently as you can.
One thing also with some of the training and even the programming side is not everybody's current with Hexagon, with their SMAs and things like that. Causes a huge rift sometimes when it's like, hey, I'm not current with my SMA. Well, you might be running 2018, 2019, 2021, and it's like, I need training on that software because the latest and greatest has, there's not huge amounts of differences sometimes, but in some cases there are. If you want to go from 2017 to 2024, that's 14 versions.
And you're able to help really bridge all 14 of those versions for them then.
Correct. And that's exactly right. Because I'm going to come in and I'm going to say, all right, let's work on your version on your machine with your parts. We're not going to pull you into a classroom. We're not going to pull you onto the latest because you're not using the latest. I don't need to show you all of the enhancements that have been made. I will probably talk about them a little bit with you as we go through the training if you're using a downed revision. Simply just so that you know that if the company if it's on the table for the company, you might consider pushing for it if there's an advantage there, right? It costs money. I mean, it's the reality of it. You want to stay current with any SMA, whether it's SolidWorks, Pc-Dmis, keep going down the list. Everything costs money. And sometimes it doesn't make sense for a manufacturer to pay every single year, year over year. But sometimes it makes a lot of sense to jump forward those 5-10 years sometimes to the latest for a year so you can get a huge amounts of enhancements all at once. So I also help some people navigate some of those things.
That's awesome. That's awesome. Well, we've now come to my favorite part of Chips and Chat, which of course is chips.
Yes, chips.
So when you and I first started having this conversation, you said you liked spicy and cheesy chips. So we went out and we found you some spicy and cheesy chips. So for our chips segment of Chips and Chat this week, we have Funyuns Spicy Queso chips. So let's open them up here. And this week we get to introduce our brand new grading scale as well.
All right.
So here we go, Matt. First one's first. There you go. Take your first crunchy crunch try. Okay. That's definitely interesting. I mean, I always was a Funyun fan growing up when I was a kid. That used to be my go-to chip.
Yep.
What do you think? What's your first impressions?
My first impression of the chip is that I would probably not go out of my way for them.
Oh, wow. Okay. All right.
I like them. Like if I would gladly eat the whole bag. If you leave it here, I probably will. But I probably wouldn't go out of my way for the queso ones. I love the original, but
the original is an institution. That's an American classic, let's face it.
I'm waiting for somebody to come out with a cheeseburger that instead of onion rings on it, they put Funyuns on it.
Oh, that sounds really good. All right, well, let's go through our categories to rate the on the official chip review scale. So
there we go.
Flavor profile, 1 being a mismatched mess, 5 being a perfect marriage of heat and cheese. Where would you rank it?
I'd put it in the middle. So I can eat anything from like Carolina Reaper hot all the way to nothing. I actually used to grow Carolina Reapers and Trinidad Scorpions and ghost peppers. Sad that I grew ghost peppers. I don't like them, but they don't taste good. But
that's a interesting hobby to pair with metrology. Is some pepper cultivation.
Yes. So if you're ever visiting me and you want something spicy, I've got I dried a couple of years ago. I had a whole slew of them, and I just dried them in a dehydrator, ground them into a powder, and it sits there. If you ever want a kick, it'll kick. I can help you with that.
Awesome. Crunch factor, number 1, soggy regret, to number 5, clean, satisfying crunch.
I actually did not think they were as crunchy as the originals. I thought that they were just a hair soggier than the original Funyuns. I don't know what do you think? I'm actually curious.
You know what? I gotta actually jump back. I didn't give it my flavor profile on that. I would match it too with a number 3 on that out of on the 5 scale. And on the 5 scale for the crunch factor, I'd have to say, you know what? It's a 3. It doesn't have that, that Funyun crunch.
Yes, yeah.
Classic
it was
Funyun crunch
just a little off from that. Yep.
But it's still a solid crunch. I mean, it's not a soggy regret.
No.
But it's not that crisp, satisfying bite either.
Yep. I'm with you on that.
All right. So heat tolerance. Spicy accuracy. Is it a false advertisement? Was it not nearly as spicy as they were advertising? Was it a good heat, or was it like number 5 would be a fiery perfection that hits the spec right on?
I would actually, so the heat did not get me right away. It waited, and I've actually got like a little burn going on in the back, but it's not intense at all. And so it's one of those, like, if I could sit there and just eat the whole bag.
Yeah.
So I'd probably give it a 4 for the heat. It's not perfection, but if I'm going to eat a chip, I don't I don't want to eat like the one chip challenge and just die. I'd rather have like just be able to sit there and munch on them. So I'd probably give it a 4 for the heat for me.
Yeah.
Or for the enjoyment.
You know, I would say for me, I would probably hit it with a 3 just because it's definitely got, it kind of reminds me of, you know, spicy queso, that the Mexican cheese dip you get at, you know, your local Mexican joint, you know, so it's kind of got that good spice to it. It wasn't, you know, right on the head where I think it should have been, but it wasn't, you know, terrible either. Cheese quality. Oh boy. Dusty disappointment would be number 1, and number 5 would be a bold, creamy, flavor-packed cheese.
I'm still hung up on the dusty disappointment.
You know,
that is amazing.
I do have to say so myself that you know that is a good way to measure the dusty disappointment. But to be honest, for me, that the cheese quality of it, I'd give it probably a 2 out of 5.
That's kind of where I was. There's nothing creamy about that. It was
no.
It was. It's good for what it is. But it's a Funyuns queso, so.
All right. So repeatability, which, you know, that's always a great term in metrology. How repeatable is our results on it? Repeatability. Would you snack on it again? 1, never again. 3, would revisit casually, or 5, would buy in bulk.
Probably going to be a 2. I'm not going to go out of my way for it, but I would gladly sit here and eat it and talk metrology all day.
You know what? And I would go with a 2 as well. It's not, you know, it's not something that I have to circle back to.
Yep.
It's not something I'm going to go out of my way to seek, but you know what? It's not something I'm going to go out of my way to avoid either.
Right.
So then, final grade. We've got 3 possible outcomes for this. In spec, it met all expectations. You'd recommend it. Needs rework. Tasty, but it's a little bit flawed. Or scrap it. It's out of spec completely, and we're putting it in the scrap bin.
This one needs a little rework. I think with some refining, I bet you that could be a lot better.
All right. You know what? I'm going to go with it too. It needs just a little bit of rework. It's definitely tasty, but it's still definitely a little bit flawed. That being said, I'm with you right there. I'm going to munch on one too while we chat. So as you're munching on that chip, I want to start talking about tools and techniques. You said Pc-Dmis Keyence are some of your specialties.
Yep.
What are some common challenges that you find users facing with these tools, and how do you assist them in overcoming them?
So I kind of touched on it a little bit earlier, because again, when somebody calls me, I don't get called when everything's going well. Like, that's just not the way it goes. Typically, it's, hey, the place is on fire, we're burning down, I need some help right now. Honestly, what I try to do is, if I've worked with a company quite a bit, I try to talk whoever I'm working with through it on the phone. I ask 2, 3, 4, 5 questions, try to get to an answer, and then if I get to, if the suggestion works, great, cool. I helped you, have a great day, right? We're not going to exchange money, we're not going to exchange anything else. We got you up and running, that's what's important. Now, if it's like, hey, the whole, the CMM's practically on fire. I don't know. It's like, all right, let's go on site. Let's work through what's going on. And then you start, you just start troubleshooting. And sometimes I get called for a probe calibration issue. And that's what it turns out being, or a bad module on a CMM. Sometimes it's something that it's like, oh boy, Matt can't even fix this one. Where it's like, you got to call Hexagon or something like that. There's been a couple of those where it's like we're getting into the SMA and things like that, where it's like it's not letting you update properly. We try uninstalling, reinstalling, it still doesn't fix it. The other thing is every machine has gremlins. That's what I call them. Every machine has them. Mm-hmm. I've never worked on a machine that didn't do something funky. And what happens is that sometimes it just does something funky. And you're like, oh, can I do it again? Well, because you got to know if it's repeatable, right?
Right.
Is it repeatable and reproducible? I don't know. We're gonna find out. The other side of it is sometimes Pc-Dmis is just a demon. That's why people call it Pc-Demon sometimes, and it's just there's not a good workaround, or it's just here's how we're going to have to work around it. I've had one of the one of the weird ones that I've had was I was actually programming the part myself, and I was watching the scan as it went around this part, and it stopped, and then it just started driving. And I'm like, where are you going? It was collecting data the entire time. I could have done a surface profile to it, and I sat there just staring at it like, how far is it going to go?
I wonder, was it humid out that day? Was the air just that thick that it was picking up solid measurements on the air? Minnesota humidity can do that.
The worst part is that it was in a temperature and humidity controlled environment.
Oh, so terrible.
I know. And I sat there and I was like,
gremlins.
Yeah. And kind of literally all I did was I adjusted my I transformed my model, which is the technical term. You transform the model before I programmed it a little bit, tweaked it a little bit, never had that issue again.
Interesting.
And sometimes it's just little things like that. It was a gremlin, so you just hope that it never comes back again.
Awesome. Well, when it comes to offline programming, you mentioned that that's been really picking up a lot for you lately.
Yep.
How do you ensure efficiency and accuracy in developing or editing the programs for your clients?
So if you send me a program, I'm going to look over it and hopefully get through whatever I can. And anything that we modify or change, I'm going to make sure that the probing path is efficient. Everybody knows about collision detection. You got to end up with no collisions unless there's a graphical error. Shout out. Not that that's ever happened where the probe's over here and says, yeah, I crashed. And you're like, no, you didn't.
Not that it's ever happened. Ever.
But it is one of those things. You're looking at your probe path. I programmed a part recently that was somewhere in the vicinity of 50 inches long. So this is a pretty long part. Well, it takes time to take points driving down this part. I'm not going to drive down this part, restart over here, drive all the way back and restart to go down, maybe a different face or something like that. This one had a pocket in it. So then I went down in, did all of it all the way through, instead of driving back and forth across the part. So that's where some of the efficiency comes in. Also, some very minor things like if you're, just doing like a profile out around a part, right? You're just taking a profile going around the part. You're not scanning it. You're doing points. Well, instead of doing point, and then when you do a circle, instead of going here, circle, back, you just go circle. So some of the probing path, you can definitely get some gains there. Sometimes it's a difficult balance between keeping your probe safe with your pre-hit and retract, keeping the probe away from the part or away from the potential fixturing, but also holding it tight because a lot of times your highest gains in time are going to be reducing your pre-hit and retract. But in order to know that you can do that, you have to prove it out and make sure that the parts are consistent. So it's one of those things. One of the things I learned is making sure that the fixturing you get nailed down before you start programming. If you have an idea of how you're going to fixture it and you don't communicate that well enough, or you don't have a model for the 246 block or the 123 block or the custom-made fixture that you're going to make, whatever the case may be, if you don't have those things, you leave yourself open to the potential of a crash. Not that that's happened before. I apologize. We weren't on the same page. We worked it out. But everybody knows that those things will happen, and you do the best that you can to mitigate the risk of that.
Exactly. Exactly. And you know what? Chips and Chat is all about being real. There's no sugar coated here.
Yep.
It all happens. We've all crashed a machine. We've all made that mistake. We've all fat fingered a number. And you know what? It's all about how we move on from it. So appreciate that one, because it provides just a scope of reality to it. Because
Yes.
these are real world problems that we deal with on a constant daily basis here like that.
Yep.
So, I appreciate that. That's really cool how you're able to help assist with all of that and do all that. Now, I wanted to kind of touch on your role at Unimatic Precision Machining. So far we've really had an opportunity to talk about what you do on the side.
Yep.
With your business at Measuring Microns. And I admire the entrepreneurial spirit and the hustle and drive to be able to be doing this, after hours while you're already maintaining a full-time job. So talking about your full-time job a little bit, as the quality manager at Unimatic Precision Machining, how does your experience there help influence your work with Measuring Microns and vice versa?
So when you're training, when you're using software or doing anything, you should be doing some form of learning with it, whatever the case may be. So when I train somebody, there's typically something I learn from them because they're going to ask a question, because that's what you do, is you ask questions to get answers. And sometimes as the trainer, you don't always know the answer. So I'm able to take that experience and bring it into Unimatic. So I am able to bring more from a CMM programming perspective to assist Unimatic, because I also do the bulkhead of our CMM programming there. So on top of being the AS9100 management representative, the quality manager, managing all of our root cause corrective actions, we can keep talking about that. But that would be one way that Measuring Microns helps and influences the full-time job, whereas going the other way, as a business owner, I know what I would be looking for as a quality manager in services provided, or how to talk to somebody. Like, what would I want to know from my supplier being a programmer? Well, I want a program that's this, this, and this. This is the information that I'm going to need. So it kind of goes back and, helps both ways a little bit. There's not a huge amount of overlap other than I program at both both jobs, so to speak. So.
Awesome. And in a previous discussion, you've shared that you've shared strategies for removing variation from processes. Could you elaborate on techniques like mistake proofing and leveraging control charts?
Yes. So how do you make sure that nobody can make a mistake? That's kind of the goal. You're making the idea with a process, any process, is how can we make it so that somebody can't make the mistake? At least if your intention is to mistake proof it, right? Sometimes we throw a process out and we know that there's going to be mistakes, and that's what we want almost. So, because you're just learning and you're trying to develop something. But once you start to pare that down, you're trying to make it where you can't load the part incorrectly. From a machining standpoint, right? I'm going to add this extra couple of tool paths in order to put this little feature in that I'm going to mill off on my next operation, but it's going to make it where I can't load this thing incorrectly. Or maybe we're going to build a fixture. We did that at Unimatic. We had a part that was basically symmetrical, side to side. I may have gone over this example actually in that previous discussion that you were talking about. But it's symmetrical, and it's a bolt hole pattern of 3 threaded holes, I believe. And the only difference is that one is 121 degrees and the other one is 119. Visually, when you look at it, you're like, oh, which one's which? Like, it's really tough to just see visually. So what we did was we made a fixture for the second operation, because you always make it right on the first operation because you're just establishing them. But when you flip it over and you've got to chamfer the back holes and things like that, I think you have to add one of them at that point, if I'm not mistaken. So we add one. So we add either the 119. So you have to make sure that you've oriented it correctly. So then we just put 2 pins in, so you couldn't put it in the machine incorrectly. From a measurement standpoint, if we're talking about automated inspection equipment, we could talk about doing things like training the people in order to do what's called a read point alignment. Effectively what that is drive the probe here, and then that is now going to be 0 from where you're going to start from. So all we needed to do is make sure that the probe is in this location, but that still depends on an operator. Or some companies have got modular fixtures that they bump into the same spot, kind of, the V. Yep, set it in here, just hit go. Somebody else has already done the pre-alignment to make sure that to link the machine to the model and, link it all up. So that would be a way to mistake-proof it. We've got one of those at Unimatic. I actually was able to run a bunch of parts this afternoon, or earlier today, rather. I just set the part in, hit go. Grab that one, next part in, hit go. So as I'm walking by, because I'm running around doing 18 other things, I just part off, part on, go. So I got through the inspection, one whole inspection basically, just walking by. So that would be some of the ways that you could mistake-proof. From a control plan standpoint, you're developing the method on kind of how you're going to measure your parts and what types of things you're going to, it's a plan that you're putting in place effectively. Control plan, words mean things. So you're going to have to get buy-in from other people to make sure that they're going to use it the way it was intended. Right? So if you put it on the control plan that you're going to measure this feature with a caliper, well, it's going to involve training. Well, how do we use a comparator? Well, I got this, 4'3" petite person that they're going to close the caliper with about this much force. And then I've got, my friend who's 6'8", and he's like, whoop, and moves the those types of things. So there's training, there's all of these things that you're going to be adding into your control plan that aren't necessarily part of the control plan, but they're the additional pieces that have to be there. Otherwise, your control plan isn't going to control things as well as you want.
Got it. That's awesome. Well, now looking ahead, what future developments or services are you planning for Measuring Microns to further assist the manufacturing community? You mentioned, obviously, staying up to date with current technology, a few other modules. Elaborate on that a little bit for us.
So it is kind of what I said before. I really want to get something out that's going to be an online platform. I think that is going to be, it's going to be a go at your own pace so that, hey, we've got this. I mean, everybody's busy. Absolutely everybody I talk to is, got way too much on their plate. Mm-hmm. It's manufacturing. We're in the Twin Cities. It's kind of par for the course. So if I offer something that is going to get somebody from, hey, I can touch the machine and it doesn't burst into flames when I touch it, to I can sit down and write, the beginnings of my program and write, and then you get a little bit further into the training and it's like I understand what's going on as I'm reading the code, and then a little bit more, but it's all at your own pace. And when you can do that on your own machine, that caters to an entirely different group of learners. Often CMM programmers are kind of the don't talk to me. I want to just program my machine, leave me alone. So if those are the type of people that are attracted to this type of role, that would be a more conducive way to train somebody potentially. So the other thing is that it doesn't take time out of my day. So then you're not paying directly for me to be there. So it's going to be at a different cost than having me come out and train somebody. It'll be a little bit less expensive for somebody to go through and train at their own pace. So
really provides that accessibility price point to, from the experienced shop owner to the guy just starting out who may not necessarily be able to afford having you come in person. So that's really awesome that you're providing that accessibility point.
Right. I've talked to a couple of people, and they're, a couple of really small manufacturers. Like, they have one machine type of small. And they're like, yep, I'm just thinking about buying my first, height gauge or something like that. And I was like, you know what? I understand. And if there's anything that I can benefit, just drawing on my experience for what's available to you. And I've gone through and helped a couple of people, a couple of small manufacturers, just with making more educated choice on what type of equipment to buy. Not even, I mean, they didn't buy anything from me. Like I literally just helped them so that they were getting what they needed to be more successful. And so that's kind of the goal. It's manufacturing is not a zero-sum game. It's not a you versus me. It's a we all need to work. If we work together well, there's a lot of available opportunity and potentially a lot more coming with some of the tariff stuff that's, been put in place, I suppose, at this point. I have a feeling that manufacturing is either going to boom because we're going to have to pull some of the stuff that's made out of, outside of the U.S. in, or like the company out of Tulsa that I referenced, Cutting Edge Technology. He said that as soon as the election ended, they kind of went boom, and they've been off to the races since then. So there's, not that we're going to get into politics by any means, but it does play into some of these things for manufacturers. Mm-hmm. So, yeah.
Lots of exciting things coming up for you at Measuring Microns, and I'm just really excited to hear how you're really helping to bridge that gap in metrology between the guys getting it done, cutting the chips on the shop floor, to the guy who's making sure that your end user is getting the right parts, and you're providing both the quality service for the end user as well as the quality service for the manufacturer as well, and bridging that so that way there's that real harmony between the two. So that's really cool to see that. So kind of wrapping up here, for those interested in your services, what's the best way to get in touch with you or learn more about what you offer at Measuring Microns?
So if you want to contact me directly, contact me through my email. It's measuringmicrons@gmail.com. That's the easiest way to get a hold of me directly. Otherwise, I'm on LinkedIn. You can look up Matt Evans. You can also look up Measuring Microns on LinkedIn. And if you are a Pc-Dmis user, follow Measuring Microns. I do a weekly post. Or 95% of the time, I get it weekly.
You get it done 100% of the time, 95% of the time.
That's right. That's exactly how it works, too. Because there are some weeks that it's just like, you know what? There has to be one thing that gives, and that's a low-hanging fruit that can give this one time. But I really try to make it valuable. I post on anything from, hey, this is an auto circle, and these are a couple of the features that are held within it, to, hey, we're going to actually discuss looping, which is actually going to be one of the next few posts coming up, is about looping inside of Pc-Dmis. A lot of Pc-Dmis users don't like looping. Me being one of them. But we're going to talk about it and hopefully go through some of the benefits for it. So there's a lot of stuff there. I've got a website, measuringmicrons.com. So if you want to go to the website, there's a beautiful picture of my family there. If you're interested in seeing us, along with staying up to date, most of the information to stay up to date comes through LinkedIn, but I'm working on getting some other stuff on the website as well.
All right. Well, can't thank you enough for all the time. Yet again, Matt Evans from Measuring Microns, everybody. Any questions you have, do not hesitate at all. This guy knows more than he lets on even here. So can't thank you enough for all the time.
Thank you so much.
And stay tuned for the next episode of Chips and Chat.